Hello, welcome to my channel. Today we are going to discuss about how to implement NOT gate in DSCH and Microwind software. So our experiment will have four parts. It will be divided into four parts. At first we will make a DSCH circuit and simulate it and get the correct timing diagram. Then in the second part we will generate a verilog file of the DSCH circuit from in the DSCH software, and then from the verilog file we will compile it in Microwind software to generate an automated layout design. In the third part we will make a layer by layer model design of the NOT gate in Microwind software, and in the fourth part we will make a transistor based design model on Microwind software from scratch. So the video will be very simple. I'm not going to speak very much in the video except for where it's needed. I expect you to follow the instructions through the video shown. So we start the experiment with a DSCH circuit construction, then we will simulate it. After we complete the DSCH circuit, we hit run for a few seconds and then we see the timing diagram. We can see that for every 0 as input we are getting 1 as output, and for every 1 as input we are getting 0 as output. So it matches the timing, it matches the truth table of the NOT gate. So our simulation is correct. You save the DSCH file in a known location and then you click make verilog file. A text file will be created in your known location in your safety directory. Then you go to the Microwind software, click compile in the above options. You click compile, then you click compile verilog file. uh, a text box or something will appear. Then you click compile in the bottom, in the lower left button. You click compile. On the lower right it will show error or no error. If it shows no error, then it's correct. Your goal is to get no error. Then you click the cross, you cancel it. Your circuit will appear. Then you hit run. In this section we are going to design a NOT gate layer by layer. Basically we will convert a stick diagram into a layer diagram, and one of the conditions for a layer by layer transistor model design is that to create a transistor, okay, to make a transistor, an NMOS or a PMOS, your polysilicon layer must cross the diffusion layer. So to make an NMOS, your polysilicon layer must cross the N plus diffusion, and to make a PMOS transistor, your polysilicon layer must cross the P plus diffusion. After making the NMOS and PMOS, you connect them through a series connection using metal 1 from the palette layers. A bit of metal to connect to ground and a bit of metal to connect to VCC. Then we know from our basics that a PMOS has an anvil. So we take an anvil from the palette layers and draw an anvil region around the PMOS, around the P plus diffusion section. Then we add a clock pulse to our polysilicon. We add a output to one of our metal. Then we hit run and we see the timing diagram for a few seconds. We can see that for every high input we are getting low as output, for every low as input we are getting high output, which is the correct timing diagram according to the truth table of NOT gate. In this section we are going to make a transistor based model design. This is very easy. We take a PMOS from the from the palette of layers. We take a PMOS, then we take an NMOS, we connect the polysilicon layer and we connect the metal layer. Then we will apply our VDD, ground and output and clock pulse, and we will look at the output, as in look at the timing diagram, and that's it. So that's it for today's video. I hope you liked it. Thank you for watching.